Hi there, I'm Lynn Borum, an Energy Service Coordinator at Middle Tennessee Electric. My primary job here at MTE is to help our members save money. As a not-for-profit local electric cooperative, we want you to use as little energy as needed to live comfortably. That's right, we want you to use less energy and spend less money each month. Hey, so let's talk a little bit about insulation and air sealing around your home and a few quick inexpensive DIY tips to improve both. Insulation, it's all around you. The floors, the ceilings, the walls. Your home uses a variety of products to insulate your home and reduce how much air escapes or comes in. Some airflow is needed to prevent issues like mold or contaminated air, but too much escaping air can cause your heating and cooling system to run too much to keep you comfortable. Depending on the age and the conditions of the materials in your home might need additional insulation to lower your monthly energy usage. Different types of insulation provide different R values per inch. The higher the R value, the more air it prevents from escaping. One of the easiest places to fix poor insulation is in your attic. And insulation efficiency has gotten better. Your attic might need more insulation to meet current energy efficiency standards. We recommend insulation at R38. This will give you a reasonable level of energy efficiency without the extra costs associated with the higher R value insulations. There are several types of insulation that you might have in your attic. You might be familiar with the rolls of the pink insulation with the brown paper back. This type of insulation is best used in vertical applications. Blown-in insulation and foam insulation are two of the most common attic insulations. They are relatively easy to add to your attic, and many companies offer this service at a relatively inexpensive price. The more attic you have, the more insulation you'll need. But it's worth the investment to reduce the amount of air escaping your home through the attic. Another way to do that is by air sealing, checking places air could escape. This includes any place that leaves an opening to your attic or the exterior wall, like light fixtures, fans, access doors, vents, outlets, and chimneys. The more gaps you have for air to escape, the more your heating and air conditioning will run to keep your home at a comfortable temperature. So how do you fix these gaps? Well, seal them up. Depending on the gap, there are different ways to close gaps and stop inside air from escaping your home or outside air from getting in. For attic and exterior doors, you should check the weather stripping. If it is broken, cracked, or dry rotting, replace it with fresh weather stripping from your local home improvement store. While you're there, pick up a tube of caulk and a caulk gun if you don't have one. Caulk is a great way to seal gaps around windows and doors. And don't forget to remove the old caulk with a putty knife first. Never put new caulk on top of old caulk because it reduces its durability and lifespans. For fans and vents, make sure that they are snug and flush to the ceiling. If you can feel attic air when you hold your hand near the mount, you probably need to tighten or caulk the fixture mount. Exterior walls also provide gaps for air to escape. Any hole in the wall, like electrical outlets and light switches, should have a piece of insulation behind the faceplate or hole cover. These cost a few cents and each are great for stopping outside air from getting inside. And last but not least, let's talk about windows. There are giant openings in your wall, and they can let in a lot of air. I mentioned caulking around the windows earlier. That's one way to make them more efficient. You make sure that they are locked to prevent additional gaps inside the frame. However, your windows can only be as efficient as the materials and framing allows. Over time, your home might shift, contract, expand, causing your windows to no longer fit properly. When this happens, caulking and locking the windows is only masking a larger issue. You may have to replace them as they age to improve their fit in your wall. There are several benefits of replacing windows when they no longer fit properly. Window materials are constantly evolving and improving. This means windows made today are more effective than windows 10 years ago. Not only are you getting a window to fit your opening, but you're also getting a more efficient window, which reduces the amount of energy you use. While replacing our windows isn't always the right choice, it might be an option you want to consider depending on the age of your home. If you decide to go that route, give us a call and our team can help you determine how to get started. Thanks for listening and watching this workshop on insulation and air sealing. If you want some help with your energy efficiency, give us a call at 877-777-9020. In addition to helping you improve your energy habits, the Energy Services team can conduct a home efficiency evaluation to spot other ways you can save energy each month and reduce your bill. Stay tuned to part 2 of today's workshop with Tim Suddoth, our in-house solar expert. He explains what to expect when installing your solar installation. Thanks, and have a great day.
Hopefully you enjoyed the first part of today's workshop. Energy efficiency and solar installations go hand in hand. The more efficient your home is, the less energy you need to generate with a solar system, and the less money you'll have to spend on that system. In this workshop, I'd like to discuss solar installation best practices, what to expect from your generation, and what kind of configurations you might see. Hi, I'm Tim Suddoth, the Distributed Energy Resources Coordinator at Middle Tennessee Electric. I work to help members with emerging technology like solar, electric vehicles, and battery storage. In fact, I'm here again today at our Lebanon office where we recently installed 60 kW solar installation paired with battery storage. This is an actively functioning microgrid designed to let us learn and study how to use the technology to benefit our members. As with any rapidly growing and evolving industry, there's a lot of information out there about solar, batteries, and microgrids, but not all the companies creating this information has your best interest in mind. With a background in solar sales and installations, I maintain a certification and accreditation through the North American Board of Certified Energy Practitioners, or NABCEP. It's something I'm passionate about, and I want to help our members make the best decisions when it comes to going solar. When you have questions about anything related to solar, I hope you'll reach out to me. As I mentioned earlier, we're talking today about the actual solar installation process and what you can expect. I'm going to try to provide this information as an overview. However, there is a bit of technical information I'm providing today. If you have any questions or want further clarification on anything related to what we talk about today, please feel free to reach out to me at tim.suddoth@mtemc.com. I'm happy to answer those more advanced or specific questions. So before you sign a contract, I recommend you research the impact solar has on your homeowner's insurance, tax situation, and the estimated total cost of an installation and that ongoing maintenance. We discussed this in detail in the first 2 workshops. If you need to review that information, you can watch them on demand at mte.com/Energy Academy or Middle Tennessee Electric's YouTube page. So with your contract signed, it's time to start installing your new PV system. Let's talk about a few best practices for this process. First and foremost, make sure that your contractor is filing permits and getting state electrical inspections once the work is completed. The safety of your home, your family, and your property is critical when installing solar. It also ensures you receive the full value of the PV system if you decide to sell your property in the future. I've mentioned this in previous workshops and I want to say it again in this one. please use a NABCEP approved contractor and a licensed electrician when installing your system. If you need help finding a recommended contractor or want to check them for solar certifications, go to nabcep.com. Secondly, when you decide to go solar, give Middle Tennessee Electric a call at 877-777-9020 or shoot me an email directly at tim.suddoth@mtemc.com. I can provide you information to help you make the most of your solar system. First off, your contractor should always use Underwriter's Laboratory listed equipment. Sometimes you'll see this abbreviated as UL, followed by a number or name on the equipment. Equipment with this rating has undergone extensive testing and is the accepted standard for quality electric applications. You may also see markings for IEEE, the standard for technical components related directly to solar PV systems. If your equipment doesn't meet UL or IEEE standards, contact me to discuss what options may be available. Your solar system will need an inverter to convert the power generated by your panels into electricity that your home can use. Make sure you use UL 1741 and IEEE 1547 listed grid-tied inverters only. Your PV system will also include solar panels. Those panels should have a UL 1703 marking on them. Because your solar panels are generating electricity, you will need to have AC disconnect fuses. As their name implies, they disconnect or stop the flow of electricity into your home or onto the grid. Your PV system will have several wall-mounted panels, disconnect switches, and meters. These should be located together and properly labeled. Your meters will need an MTE tamper seal or lock. You need to know where the disconnect panel is and be able to identify it for emergency personnel in the event of a fire or natural disaster to your home. Display warning labels or signs to make first responders aware of the danger when you're not at home. Your system must also pass an emergency shutdown test. This test is used to ensure your system is not backfeeding onto the grid in the event of a power outage. Backfed lines during outages can cause injury or death to line workers, civilians, or emergency personnel working in the area. Keep your equipment and wires out of direct sunlight when possible. This can wear down or overheat the equipment and lead to additional maintenance costs over time. We're obviously not talking about the panels here, but I can't tell you how many installations I've seen with wires hanging loose or touching the roof. You do not want your wires touching asphalt, shingles, or metal. Roofs can get upwards of 150 degrees in the summertime and it'll eat through that jacket, as well as wind blowing it, scraping against that shingle. And again, not only does sunlight deteriorate the equipment, but animals and storm debris can cause damage as well. Every time one of these little things happens, it costs money to fix. So make sure it's protected within reason. Contractors will need to protect this wiring using conduits. Conduits are used primarily for the larger wires, but smaller wires connecting the panels should be neatly tied under the panels attached to the racking for protection. Unprotected wires are unsafe and could lead to injury or worse. If your wires are unprotected, they can also fail sooner than they should. Don't forget that any buried electric lines will need to meet state and local codes. Your roof should have at least 25 years of life left before installing a system on it. And if that roof is in good shape, the solar panels should face south for maximum generation. Because you're creating holes in your roof to mount your panels and racking, make sure all roof penetrations are flashed and sealed to prevent leaks. Ask your contractor how they will do this. No matter how small or large, the holes in your roof can lead to water damage. If your roof leaks, you'll have to take some or all of the panels off to fix it. Try to avoid this to save money down the road. I know that this is a lot of information to take in and it might feel overwhelming. That's why we've created a handout you can download outlining these items and more at mte.com/solar. We know solar is a big investment. We want you to have all of the information to stay informed and identify potential issues before they happen. We want to help you through the process, so please contact us before, during, or even after your installation when you have questions or concerns. I know that is a lot of information, but this is a complicated product. However, Middle Tennessee Electric is here to help you navigate issues when they arise. In fact, we have resources to let you maximize the potential of your solar system. Middle Tennessee Electric is a distribution electric cooperative. That means we buy power from the Tennessee Valley Authority, or TVA. In Tennessee, you can't simply generate power and send it back onto the grid. If you want to sell excess electricity you generate, you'll need to sign up and participate in TVA's Dispersed Power Production Program. This is called DPP, and it allows you to sell energy back to TVA at roughly 2 cents per kilowatt hour. You'll sign a 5-year contract with TVA with the option to renew after 5 years. TVA will pay you for the energy each month with a direct deposit to your bank account. Middle Tennessee Electric acts as the point of contact for you to apply for the program or to answer questions. However, we don't manage or have any control over the DPP program or contracts. This program is great for members with systems generating more electricity than they use each day, or for members without a battery storage system. If you're not selling power back to TVA, you can install behind the meter configuration, commonly referred to as BTM. This configuration means that you're generating electricity at the same rate that you buy it. However, if you don't use the generated electricity, it is automatically pushed back onto the grid with no compensation. This configuration is best for members who plan to use their energy immediately or expect their energy usage to exceed what they're going to generate. Both behind the meter and DPP solar configurations can use a battery storage system. For behind the meter setups, your battery stores excess energy to use at night, during low power periods of the day, or during outages. It's a great way to make the most of your solar installation. DPP participants can also use energy storage, and any electricity generated above and beyond the storage capacity of the battery is sold back to TVA at roughly 2 cents a kilowatt hour. So knowing when you use your energy is critical to properly sizing and configuring your solar and battery storage system. That's why you should use contractors who ask for hourly usage. A quality solar contractor will always ask for the hourly meter data to help determine the size of your system. As you can see in the graphs here, this home generates 5 kW differently depending on the time of the year. The one in June generates more energy during the day than the one in December. However, your solar PV system may not make the most of that generated electricity. That means you're wasting energy or your system won't meet your expectations. When you decide to go solar, contact Middle Tennessee Electric. We're committed to helping you achieve your solar goals. From building your own PV system to participating in one of our programs, Middle Tennessee Electric has a green solution to fit your needs. You can view our solar programs, view our recommended contractor network, or get more information about installing your own solar at mte.com/solar. Thanks for watching today, and I hope you plan to watch the final workshop in this series. We'll talk about what you can expect as the owner of your own system. Of course, you can watch this workshop along with the rest of the series on demand at mte.com/Energy Academy or the Middle Tennessee Electric YouTube page. I look forward to seeing you then, and I hope you have a great day.